Hi everyone, my name is Lee Pucker. I'm the CEO of the Wireless Innovation Forum, and I'd like to welcome you to the 29th in our WInnForum webinar series. Today's webinar is entitled, We've Got PAL, Now What? With a focus on the future of CBRS. A few administrative notes before we get started. First, the slides presented during this webinar are going to be available. They're actually not in the handout section, but they will be available on our website. You can go to wirelessinnovation.org/webinars, and you'll be able to get the slides there later today. There will also be a link there to a recording of this webinar. We're recording as we go, and so you'll be able to view the recording in once it gets uploaded again later today. If you have any questions at all about how to access this information or anything else related to the webinar, please feel free to email me at lee.pucker@wirelessinnovation.org, and I'll be happy to help you out. So with that, I'm going to turn it over to today's moderator. The moderator for today's webinar is Mark Gibson. Mark is the Director of Business Development of CommScope, and he's the Vice Chair of the Wireless Innovation Forum. So welcome, Mark.
Thanks, Lee, and I will take it from you right now. Stand by, and while I get it up.
All right, you should have it.
Yep. Okay, so can I get a check to make sure that you're showing my deck?
I think you're sharing your other screen, Mark.
No. Okay. All right, stand by.
There you go.
Okay, sorry about that. Okay, so the title of today's webinar is We've Got PAL, Now What? So what's the future of CBRS? So I've got a couple of slides to set this up. Everybody knows what the auction results were. The gross proceeds were about almost 4.6 billion. There were the most people that were qualified and participated in this auction than in any other auction the commission has had to date. So it was a very, at least, interesting auction for 271 or 228 people. So far, the number of licenses won is about 20,625 in 2,946 counties. That means 287 counties didn't have licenses sold so far. 2,006 licenses weren't sold yet. The commission will probably go back and re-auction them sometime in the future. The average dollar per megahertz pop is about 21 cents. That's on par with some of the other auctions. A little low, but generally on par with some of the AWS. Actually, AWS is 95 cents, but some of them it was pretty much on par. And you see the list of winners there on the right. Top two winners were Verizon and Dish. Dish won 5,492 licenses, so they have the lion's share of the licenses, more than a lot of them other added up. And then number two is Verizon, and then the others followed after that. So that's who won what. The CBSD growth from the beginning. This sort of shows just the aggregate number of CBSDs that have been deployed. We're around 142,000 as of last week. Growth is around 43% annually, but you can see that the numbers are ticking up, and the numbers from May are as of last week as well. And most people know more Category B than Category A have been deployed. We'll get into those reasons as we go through the presentations today. One interesting thing we've looked at, and you'll hear this from Masoud when we talk about PAL channel assignment. I took a look, and we have this data. This data is as of May 3rd. This is the selection of PAL channels from the various licensees. Masoud will explain how that worked, but essentially the SASs collaborated to develop a portal that would allow the PAL licensees to select channels. And when you look at it in terms of everybody, aggregate with everybody, not including Dish, who, you know, again, won almost 5,500 channels, it's pretty, there's a bias toward number one. So that means Dish chose a lot in their markets of the lowest channel, but pretty much average across all of them. And when you look at it without Dish, then there was a higher bias toward channels above, you know, 4 and above. But, you know, there was, you know, really, we could do some more statistics on it, but it just kind of shows that people wanted to avoid the lower channels, probably 1, 2, and 3 for obvious reasons. One of which is its proximity to 3.45 gig below. So anyhow, that's just a little bit more context for today's presentations. So here's who's going to be speaking. We're going to start off with Matt Mangriotis, who's the Senior Director of Product Management at Cambium. Matt's going to be speaking about CBRS deployment successes and challenges. Matt has 20 years in the telecommunications business. Obviously, he's with Cambium now. Matt has several degrees, including a master's, a bachelor's, as well as an MBA. And Matt has been involved with this from the very beginning. In fact, everybody that you see there has been involved with CBRS pretty much from the beginning. So we're all seasoned veterans. After Matt will be Dr. Masoud Olfat. Masoud is the Vice President of Technology Development with Federated Wireless. He will be speaking about PAL channel allocation and swapping. Matt has been with Federated since they started for the most part and has a very varied career in his technology, dealing with things like Wi-Fi, WiMAX, LTE, 5G. Masoud is a standards guy and has participated for years in standards and is one of the key folks at Federated dealing with a lot of the technology and wireless issues. After Masoud is Max Solondz. Max is the CMTS radio specialist at Verizon, working in the CTO area. Max is going to talk about PAL secondary market sales and leasing. Max has been with Verizon for a while and 35 years in the business, so has pretty much close to what I have in the business. Max has been with Bell Labs, Lucent, ALU, and whatnot. And again, Max has been with this from the beginning. Has a lot of experience with radio and radio technologies. After Max will be Richard Bernhardt. Richard is the National Spectrum Advisor for WISPA. Richard is going to talk on CBRS markets moving forward. And Richard is the principal advisor for WISPA and their national spectrum advisor, like I said. Richard is a lawyer, so he's the only lawyer on the panel, so he will be good about not taking us to task for anything we say. But he's had a lot of experience in the industry, working both with WISPs and with WISPA. And then batting cleanup is Andy Clegg. Andy is the spectrum engineering lead at Google, and he'll be speaking from a WInnForum perspective on spectrum sharing committee work from the Working Group 1 chair perspective. And Andy's been with Google for quite a while, 5 or 8 years, I forget exactly how long. Before that, Andy was with the National Science Foundation. Before that, Andy was with AT&T, actually with ComSearch. And also, Andy got his PhD from Cornell. So that's our lineup. So with that, I will bring up the first deck, which is Matt's deck. And Matt, you're on.
Hello. Thanks, Mark. Appreciate that. And you can go ahead and flip to the slides.
There you go. Whoops.
Thanks. So I just wanted to very briefly introduce Cambium for those that don't know who we are. We are a company that spun out of Motorola a while ago, about 10 years ago now. And we like to think of ourselves as pioneers or market leaders in point-to-point and point-to-multipoint. And since then, we've diversified, and we're covering lots of different things. We like to think of ourselves as having a wireless fabric that suits any wireless solution needs. We've been involved in CBRS for quite some time, for many years, in fact, knowing that it was the logical conclusion to the Part 90 deployment. And so we got involved early. We made sure that the non-standard solutions were allowed and not discriminated against while the rules were being formed. So that was one of the very important things that we did, getting involved early. That said, go ahead, go to the next slide. So our main use case in this space, in the CBRS space, and by ours, I mean our customers, are mostly service providers and mostly rural service providers. And that fixed wireless use case for CBRS is the primary and the first mover. And I think based on the numbers that everyone understands, we are still the majority, we meaning the fixed wireless service provider, are still the majority of the users of the band at this time. Certainly there's other use cases that are coming on board and going to be large in the future. But as far as the number of devices that are registered with the SAS and operating in CBRS, the vast majority is the fixed wireless use case. And that includes things like multi-point distribution, residential access, business and enterprise access. There's all kinds of different use cases wrapped up in that, but the fixed wireless use case is certainly the biggest user of CBRS and the first mover. A lot of that has to do with the Part 90 to Part 96 migration that took place. Go ahead and go to the next slide. As far as what Cambium does and how we operate, we have what we call the 450 platform of multi-point devices. And this is, again, it's non-standard. It's not an LTE device as such. We've found that this purpose-built fixed wireless solution actually provides several advantages over a standards-based solution in this space. And so we've pursued the innovation along this platform, and we've had great results from customers. We work with all of the major SaaS providers, Federated, Google, and CommScope, all of which are represented on this panel. And we enter into a direct business relationship to provide that CBRS service. So we can, if necessary, migrate from one SaaS to the other, depending on who is best suited to service that customer. So again, we took our existing equipment that operated in Part 90 and we enabled it through software and through new FCC IDs and new FCC grants to migrate to the Part 96. And the vast majority of what was installed, we're estimating about 80% of what was installed in Part 90 has now migrated to CBRS over this past year and a half or so. And it's been a great transition. We've learned a ton. We've come a long way from the beginning. And we suspect there's still a few stragglers out there, of course, but we've enabled this transition to the new regime, if you will, the new paradigm. And it's a pretty great success story. So keep going. I do want to point out a couple of particular customers that have, we've talked about these on a couple of webinars before, and I'm going to go really fast through these slides so I don't take up more time. A wireless, et cetera, go ahead to the next slide, is a service provider in Arkansas and connecting rural America. We have a case study available on the website, but their increased power levels have allowed enhanced range, enhanced coverage, additional customers, and all of this is due to the changes from Part 90 to Part 96 available in CBRS. Keep going. Next slide. Again, their main site now can service hundreds of customers, whereas before they were kind of constrained by the amount of bandwidth they had. And now with the higher power levels allowed in CBRS, they're able to service a larger area as well. Keep going. You can skip over this one. Another customer is in Colorado in the mountain areas, and they service kind of the resort towns, the ski hills, if you will. Keep going to the next slide. Zircle Wireless. They're out in Steamboat Springs area. They began using 365 with another vendor and then have since switched to 450 and have been deploying that for quite some time. Keep going to the next slide. On their main tower in that site, they've seen the transition from Part 90 to CBRS has brought them, again, additional channels, additional coverage. Again, the same fixed use case, fixed wireless use case has provided an avenue to enhance their coverage, enhance their packages, and enhance their number of customers that they can serve. So it's been a great transition for them as well. Go ahead and go to the next slide. So those were just a couple examples of great results from deploying or from this transition from Part 90 to Part 96. Again, allows higher power. It's typically cleaner. So it allows you to add additional customers and extend your coverage range. Migration really did require careful consideration from the customers. You can't add, without any knowledge or any planning, just migrate and switch over. It does require some consideration. The networking planning, geolocation is a necessity of CBRS. So some of that research was required. But we had some tools to help as a company. Cambium provides a spreadsheet tool to help with this migration and even the calculation of those azimuths and the GPS data. By and large, able to complete that activity, the transition. So like I said, we estimate about 80% of our customer base has now transitioned over to Part 96. And I do want to point out that we believe that Cambium has really fantastic support for our customers and our service providers. There are many issues with CBRS, and I'll get to those in just a second, because one of the things that I'm covering is kind of the challenges that our customers are seeing going forward. But as these issues arise, Cambium support has been top-notch in order to take care of issues and resolve them in a timely manner. And we believe, as a company, our relationship with all three of the SaaS administrators that we're engaged with has been a huge benefit to the band in general. We try to be collaborative and completely transparent. A lot of times the timing between the different SaaS implementations of different features are slightly different, so we have to accommodate that. And we can also feed back information. Hey, this SaaS is doing this next week. This SaaS is doing that. It helps kind of keep that transparency and the competitiveness to elevate the entire band. Go ahead and go to the next slide. There are some challenges still remaining though. Early on, I think some customers had some very unrealistic expectations of what to expect in using the band. Some of the the table was set to, hey, you go in CBRS and it'll manage everything. Don't worry about interference. Everything will be taken care of. That obviously was not the case. There were some challenges getting going. And then if you're in a coastal region or have the DPA issues that could be affecting your network, a lot of growing pains there, learning what to do, learning what not to do. They are still an issue, right? Some of the sensing networks have had challenges. I won't go into detail on that. I could spend a long time talking about that, but some of the folks that are operating in those areas continue to face some challenges there. PALs. So the most recent big change in the band has been the PAL implementation. It's been okay for the vast majority of people, but some of the folks that maybe weren't really involved bid on PALs and perhaps made a selection that maybe just they didn't understand, why things were the way they were, or what channels they should have selected based on some of the networking aspects around them. Maybe they thought they're not getting their money's worth. We've run into that a few times. And then the other big one that we're seeing quite a bit of now is the cross county or beyond the border of the county operating in there. How do we accommodate for that, or how does the band accommodate for that? It maybe wasn't considered as much during the rulemaking, and now we have to figure out how we're going to take care of that. But there are new features coming, and it's getting better every day, and I'm sure that folks on the panel will cover a lot of this stuff, so I'm not going to go into too much detail. But coexistence, alternate channel support, automatic channel assignment and enforcement, and then even device measurement feedback would really help get things moving in the right direction and keep things moving in the right direction. So with that, I think that's it for me. I don't want to, again, take up too much time, and I'll pass it back to Mark. Thank you for allowing me to speak.
Thanks, Matt. I did have one question I wanted to ask really quick. So there was, when I showed the CBSD deployment numbers, a substantial number of them are, Part 90, not Part 96 transition. Where do you think we are in that? Are we in the middle? Are we toward the end? What are you seeing there?
Yeah, well, so like I said, I think about 80% of the installed base or so, between 80 and 80 or so percent of our installed base in Part 90 has made the move. We've seen the numbers. We believe that that's true, which means there's still a pretty decent chunk of folks, either operating in Part 90 or have since left the band and pursued, unlicensed or what have you. With that said, however, we've also seen the use of 365 grow, right? The use of CBRS has grown. So our total install base now is much larger than it was pre-Part 96. But yes, we've seen the transition. I think the transition has slowed significantly over the last 3 or 4 months, but it's still coming. It's still happening. We do see that happening quite often. Great.
Okay. All right. We'll have more Q&A later, but thanks for that little bit there.
Thank you.
Okay, so now I'm going to bring up Masoud Olfat. Masoud, have at it.
Okay, thank you very much, Mark. Appreciate the time. So If you go to next page, let me just make sure that I make a disclaimer that a lot of activities, including PAL channel mapping process, that was a multi-SAS operation and all SASs were involved. So what I'm presenting here is our view and our understanding of the coordination and the activities and the results. Of course, if anything is not in line, other SAS admins have the right to provide their different opinion. Next page, please. So everybody is aware of the distinction between PAL and GAA. By the way, because I have a short time, I just cover just a few points, and then if other questions are remained, I'll be happy to answer later. So everybody is aware that PAL is the priority access license, which is 70 megahertz or seven licenses or 70 megahertz within the first 100 megahertz, and they are use it or share it. In other words, if they are not used, then GAA users can use that channel, that spectrum. The upper 50 is dedicated to GAA, and no PAL can operate there. Next page, please. So what happened was Mark showed the right table. I don't have to discuss that. What happened was FCC decided from day one that they only auction the licenses, which means that the actual physical channel that are going to be used by the as PAL is not going to be auctioned by FCC. So a PAL by FCC's terminology means one 10 megahertz channel within a license area which was defined as a county and for a term of 10 years. So basically the three dimensions of PAL were defined, and then it was FCC considered that as part of a SAS admin's responsibility to identify the actual channel that the operator would work on. So I'm not going to go through a lot of numbers that you see in this page, which Mark described. Let me focus only on a few numbers which are related to the PAL channel mapping process. So the number of counties was 3,220, and the number of licenses unsold was about 2,006, and the number of licenses sold was 2,625. Considering that every county have up to 7 licenses, you can come up with these numbers. And by the end of April, we have had more information in May, which I didn't count in this page. We had 228 winning bidders, and there were based 245. I'm sorry, with a second PN, and the number of licenses fully granted were 220 out of those, and remaining bidders to be granted are 25. And the number of licenses granted by the end of April was 17,450, and the remaining licenses to be granted was 3,175. Keep in mind that in the PAL channel mapping process that I'm going to explain, we provided PAL channels to all licenses, whether they were granted or non-granted. However, the operation of the PAL channels are basically contingent to the fact that they are fully and officially granted by FCC. Next page, please. So to perform PAL channel mapping, just some background is that this is what I just explained, that FCC just provides the license. FCC in WInnForum, what we decided 4 or 5 years ago was that in order to make sure that the coordination among SAS admins are applied, we provide a steady state channel to each license. So, which means that even though FCC does not allocate the channel, we run an algorithm that in a fair manner, we identify the PAL channel for each license, and we include that in a database, and which all SAS admins and our public have access to. And to that end, we created a kind of a coalition among SAS administrators, and we developed an algorithm to apply this. In order to do this, we had to take into account several aspects. Some of them are related to FCC requirements, which I'm going to explain in the next page, and other aspects were issues related to the presence of encumbrances in each channel. There are some channels that we have incumbents, such as FSS or other incumbents, and there are some channels that in some areas there is no incumbent. We should have taken that into account, as well as the potential out-of-band emission requirement that normally when you are below toward the start of the band, you have more restricted out-of-band emission requirement. In addition to this, we had two requirements from FCC, which if you go to the next page, FCC required that as long as it is feasible, it was not a harsh requirement, but says feasibility, we needed to provide the contiguous geographic area, which means that if we have a licensee that they have license on two adjacent counties or license area, we should make our all effort to give the same channel to those operators, as well as the contiguous channels, which means that if an operator has multiple licenses within the same county, we should do all our best to give contiguous channel to that operator. So these were the two requirements that we had in mind, in addition to those issues that I mentioned, encumbrances and out-of-band emission. So considering that there are 3,220 counties and about close to 21,000 licenses, and taking into account all of these criteria and the fairness, we decided to develop a portal. And in that portal, we requested the operators to provide their desired channel. So in other words, they could have looked at all the information about the encumbrances were available. We had a TR technical report in WInnForum that identified different type of encumbrances and where they are located. And we also provided a long time for operators to make that decision. If you go to next page, the timing that we developed let me just tell you the process and I'll talk about the timeline. So the process that we had was, we developed a portal, we allocated username, password to all the PAL licensees. Then the operators could go into the portal and provide their input. And the input that they wanted to provide was their channel preferences, whether they want contiguous channels or not, which we believe that in many cases they wanted, and also whether they want geo-contiguity preferences, which means that whether they require contiguity across multiple counties. So even though we relied on these inputs from operators, inside our algorithm also we prioritize the geo-contiguity as well as contiguous channels within a county. So then we spend a long amount of time to do the processing of inputs to make sure that based on the inputs that the operator provide, we have the fair channel allocation. Then we had a time frame that we allowed channel swapping, which means that, by the way, as you know, out of the 10 channels, 7 channels were assigned. So the other 3 channels, we call them unassigned. So the operators could either swap the channel among themselves or request swapping to some of those unassigned channels. So we ran a process with that, and as long as there was not conflict, we accepted those requested. We tried to do the conflict resolution. There were so many requests, so we were working around the clock to make sure that everything is fair for all operators. And then we provided the final channel assignment in a database that initially we provided that to the operators. Operators could go into the portal and see the assignment. In addition to that, we included all of them in a database, and database is publicly available in the WInnForum site. And of course, after all channels were allocated, we enabled the commercial PAL deployment. So if you go to next page, that's the time frame that we used. Next page, please. Yeah. So before that, I'm sorry, the timeline. Yeah. So as you see, we started toward the end of December, and we allowed people to provide their input until early March. So it was about 2.5 months time that operators could provide their input. So Matt raised the concern that some people didn't know. So we had a lot of interaction. I personally spent day and night time with operators, talking to them through email, and I know other SaaS admins has done that. So we try to make sure that they are aware of the concerns. So we did all we could to make sure the majority of operators have the opportunity, and also they are aware of the situation. So this portal was open for about 2.5 months, more than 2.5 months, for people to provide their input. Then we spent about close to maybe 12 days or 2 weeks, I'm sorry, to do the input processing, and then we provided the initial result on March 22nd. We spent about 2 weeks, a little more than 2 weeks, or 3 weeks, sorry, for channel swapping opportunity, so that they can provide their channel swapping request. We processed all their channel swapping, and then on March 16, we finalized April 16, 4/16, we finalized all the channel assignments. During that time, SaaS admins performed some testing and interoperability and preparation, and we made April 19 as the official date that all SaaS admins are capable of commercially enabling PAL, which means that the PAL protection actually started that day. I want to repeat that the channel assignment were provided for all licenses. However, the commercial enablement applies only to the licenses that are granted by the FCC. And as new licenses are granted, they can operate. Next page, please.
And Masoud, do you think you could wrap it up in a minute? We're running a little long.
Yes, I will do that. So 2 more items that I talk for leasing and spectrum, the secondary spectrum usage. There is a process that is being worked out between the SaaS admins and FCC. It is called light touch process. It requires the SaaS admins to use that API. It's an API that SaaS admins would get the information about the leasing opportunity, including county, PAL ID, number of lessors, number of lessees, and areas to be name of lessors and lessees, and the areas to be leased. And then SaaSes can use that API to enter that into the FCC database, and we get the response within minutes actually, and that makes the leasing very efficient. And if you go to next page, which I guess is my last page. Maybe I have 2 pages, but I summarized that. So I had 2 pages to discuss how we do actually PAL protection. Very simple. The PAL holders, they provide the registered CBSDs, and somehow we identify that they want to use the system as PAL. So we generate something called a PAL protection area based on some criteria, which is included in next page. And then we share those among the SaaS admins. Yeah, here is that's good, thank you. So as you see, each of those kind of ellipsoid areas are PPAs, PAL protection area. They could be inside one county, or potentially they could go across counties. I think as Matt said, that is already included in our implementations. They could go across the county if the same operator has the same channel on 2 counties. So then we share that information among SaaS admins, and then what happens is that all SaaS admins apply the coordinated algorithm called IAP, so that the aggregate interference to every point within that PPA is less than or equal minus 80 dBm per 10 megahertz. And that interference could come from any CBSD using that grant within 40 kilometers of that PP, any point of that PP. So that is coordinated, and that coordination happens every 24 hours among SaaS admins. And just the last point is that, and if you go back, sorry, Mark, just the last point, the PPAs are generated based on some criteria, which is minus 96 dBm 10 megahertz contour per each CBSD. In other words, we create a a coverage area for each CBSD based on this criteria, and then we use the union of those, and that defines the PPA, and we share that with other SaaS admins. So let me stop here, and if there is any question, I'd be happy to answer. Thank you.
Thanks, Masoud. I think in the interest of time, we'll move on to Max, but you did a really good job breaking down something very complex that's taken us a long time to work on, so thank you. Max is up now, so stand by while I bring your slides up, Max.
Thanks. Hello, folks. Okay, so I work for Verizon, and I've been one of the lead roles in Working Group 5 to talk about how to support sales and leasing. We can go to the next slide. So there are basically two documents that Working Group 5 has worked on to frame this. The more important one, I guess, is the framework, the 5007 document, because that document extends the framework. So far, WINForum has built the protocols and the interfaces and the databases to allow the SaaSes to assess and manage the interference and manage the channels, and then communicate the assignments, the channels, and the PPAs to and from the CBSD radios, and then also to manage the coordination between the SaaSes among themselves and amongst the databases. And you'll see that in the next slide. So that's the more broader framework, and the things that we wanted to add. Oh, no, I'm not there yet. That's the broader framework that we wanted to extend to also support leasing, specifically in Part 96 to support the FCC's notion of a light touch leasing, where instead of a mechanical filing of Form 608, that there might be automated or semi-automated methods through the SaaS or through a broker, where a smaller portion of a county could be leased from a land, from a PAL holder to a tenant, and allow the tenant to make PPA claims and use of that license for a fee. So that's the light touch leasing paradigm. And then the other document, the 5004 document, that was the more narrow scope of what new data elements would be needed in the FCC's own ULS sales and leasing agreement database, where basically primarily what that database holds is, amongst other things, including various aspects of the lessor and the lessee, basically the polygons of the area that are being transferred from the landlord to the tenant. So that's basically the leasing agreement is the area that's being leased, and the start and the stop date and all that kind of stuff. So when we looked at this, we assumed that there would be changes to the FCC ULS leasing database, and we presented our findings and the changes that we wanted to propose on a meeting with the FCC on the 22nd of April, and it became pretty apparent that for various constraints, the FCC was not really willing to make a lot of changes to the ULS database or the API applications that talk to and from that database. So now we're kind of have to reform and rework and rethink our approach, and I'll explain where we are now and where we need to go. So let's now go to the next slide. So there were a couple of new concepts that WINForum is proposing here to support the leasing and the brokering of leases. So one new concept is back reporting, where every PPA claim that a claimant makes against his own managing SaaS is back reported to the claimant, so that these polygons of where the PPAs currently exist for the landlord or the lessor can be known to the lessor's market maker. So, if a landlord decided he wanted to lease to tenants, he would tell the SaaS or his broker, here are the existing places where I have already deployed PPAs, and those are the places where obviously I don't want to lease. So that avoids conflicts and overlaps that might be made by mistake. Another concept is the precursor area, and that's basically in the state of play as things go on and more properties may be transferred by leases, what areas are currently owned, leased and disaggregated or sold that still exist in the landlord's holding. So the idea is, what can you make available for leasing? That's the precursor area. And then there are two separate areas that come out of that every time a sale or a lease occurs. There's the transferred piece, the piece that the landlord then transfers to the tenant, or a tenant transfers to a subtenant. And there's the retained piece, the piece that you didn't transfer. And it's important to identify the retained sub area to avoid the problem of recursion, because if you only record the pieces that are transferred, then for the SASs to figure out what the landlord still has, you have to go through a recursion process of subtracting all the transfers first. And that's cumbersome over time as more and more areas are transferred. So it's nice to know what's retained. Then there's the idea of automated filings under the light touch leasing paradigm, where the broker, the managing SAS, or the landlord himself could file, through a website or other automated means to post these leases, execute these leases, and then put these leases into the ULS database once they were finalized. And the last idea was, if we do all this work for leasing, couldn't we apply the same overall framework to a sale? The only difference between a lease and a sale is a lease is a temporary amount of time that the transfer, has legitimacy, whereas a sale is essentially a permanent transfer for the rest of the 10 years of the area from the landlord to the new owner. So those are the new concepts that we're talking about. Let's go to the next slide now. So this was the existing framework that we contemplated, and on the bottom is all of the existing WINForum framework to allow the SASs to manage how they create PPAs to manage PAL rights. And I won't go through all of it because it's rather complex. But the three new areas that we talked about is on the left, the red PPA back reporting to allow the managing SAS to tell the user, to tell his market maker what existing PPAs exist on the part of the landlord. And then all the way over on the right, in the green, the managing SAS, after a lease is executed, records that transaction into the FCC ULS hosted database that includes the PAL sales and leasing database highlighted in the yellow there. So that's the polygon that is recorded that tells the FCC this is the portion that's transferred. And we additionally wanted to put other information into the PAL sales and leasing database as shown here. And it seems that the FCC will, for resource constraints, will reject making any of those changes. So this is what was originally proposed in 5007 and 5004. So let's go to the next slide. So moving forward, we have to come up with a new paradigm where the transaction records from the green, the transaction recording, goes into two places, into both the ULS database as shown all the way over on the right, but also into an additional WINForum managed PAL sales and leasing database for the extra components that we want to record for, say, the precursor areas or the retained areas, and other information that would help foster leasing and let all of this work together. So now we have to create this new WINForum PAL sales and leasing database, which is basically a sister database to the FCC ULS database, and there's some kind of linkage. And we wanted to avoid that in the beginning because of the complexity of linking and synchronizing two databases. But given that the FCC doesn't want to make extensive changes to their ULS database, I think we're going to be forced into having two databases that are synchronized. So this now is the new work that Working Group 5 has to undertake to define the WINForum sales and leasing database and the information sets, and also the synchronization process. So I think that's where we are now. Let's go to the next slide. So this was the proposed information set, and I won't spend a lot of time on this, but there's a file number, the additional information highlighted in the red, the record creator who's creating the new record, whether it's a sales or a lease indication, what the precursor area is, which the FCC doesn't really define a precursor area, and the FCC doesn't put into the ULS database anything about a retained polygon for what the landlord is not transferring. But most of the other information is already in some form in the ULS database. So that's the changes that we would have to make highlighted in red. So let's go to the next slide. And this basically repeats that. So let's go to the next slide. And so here's the notion of what happens when a lease happens. The purple county shows the whole county. It shows 2 PPAs that the landlord has already created, highlighted in a lighter blue and the yellowish boundary. And it shows a PAL reservation area in the middle there, which is the area that the landlord is willing to transfer to the tenant. So at some point, that area is posted to a broker, and maybe some potential tenants who are interested bid on that, and they transact and they decide for a certain price that they're both happy, and the landlord agrees to transfer it to the tenant. So that's the FNID that's then, that file is then recorded with the FCC to define that polygon that the FCC notes has been transferred from the landlord to the tenant, and the tenant can now use it. And now all the SASs can also see this and know where PPAs can be claimed either by the landlord or by the tenant, depending on whether you're talking about the whole purple area or that green area that the tenant now has. And then the new notion is that all the way over on the right, that the FCC has retained the entire turquoise section, and that avoids recursion. So we don't need to subtract all the green portions from the purple to derive what the landlord still has. So that's why we believe that filing retained areas is important. Let's go to the next slide. Without that, then to determine what's left, the SASs would always have to go through a process of recursion where they would have to find all of the transferred areas that a specific county had and subtract them out before they could serve the landlord, because they wouldn't know what the landlord actually had retained without doing this. So that's a cumbersome process, and we wish to avoid that. So that was one of the major things that I think we're missing from the current FCC's definition of the ULS sales and leasing database. Let's go to the next slide. I think we're done.
Yep, that's it. Okay. All right, thanks.
Okay.
I have one quick question, just in general. So does this framework need to be in place before we can support leasing, or is there a shortcut approach that we can use to at least allow some level of leasing?
Well, certainly people can still use Form 608, the mechanical way. So one of the issues for the mechanical way is the map of the lease has to be transferred into electronic format so that there's a polygon, because obviously the SASs need to have the polygon of the transferred area. And if only that is transferred and put into the FCC ULS database, all of that can happen, but nothing would be automated. So there'd be no broker, there'd be no website to see it, there'd be no way to have an automated, Amazon or eBay type auction to figure out if you could buy it. And it's important, I think, for micro leasing to occur, because at the county level and the small portions that people might want to transfer, it needs to be, semi-automated and web-based.
Okay. All right. Thanks. Very good. Now I'm going to move on to Richard.
Hello.
Hello, Richard.
Welcome, everybody. I'm going to take you away from the super technical, and I'm going to bring you down to who's using this band and why it's so exciting. And to be honest with you, I think we live in a time, and we've been in a time for the past few years, where spectrum has come of age. For many, many years, there was little or no activity in spectrum. It moved along at a very, very small, slow pace, but not the case anymore. And I'm going to walk through a little bit of what the use cases are and the markets are very rapidly for CBRS. But I want to throw out there the understanding that there's also other bands which are coming up alongside and which work quite well with CBRS. And again, it's a truly exciting time to be working in the wireless and telecommunications industry, because for the first time we have quite a few options, and those options extend from the very large to the very small. My name is Richard Bernhardt. I'm the National Spectrum Advisor for WISPA. WISPA is the Wireless Internet Service Providers Association. We are made up of about 1,000 members, of which about 700 or 800 are spread out across the United States as ISPs, providing fixed wireless services across the country. My contact information is on the screen. If you'd like to get a hold of me for any reason after this presentation, please feel free. Let's delve a little bit into who's using CBRS now and what it means to be in CBRS. So if you were choosing a market to deploy CBRS these days, you will be among good and diverse company. A year, 16 months ago or so, when we first started with CBRS and ICD and got into full commercialization, we had very, very few people in the band. It was an experimental band with a few users, and the beginning of the transition of Part 90 to Part 96, as Matt indicated quite eloquently earlier today. But now, the diversity of users has grown to almost as many different ways as you can think. CBRS is designated by 3GPP as a 5G capable band, which means a lot of the 5G capable applications can work on the 3550 to 3700 band. And that means that cellular and mobile providers, as well as fixed providers, can use this band, and they can do so with LTE, or they can do so with proprietary air interfaces. One of the unique things about CBRS is it is technology neutral, and it does allow for a wide choice of different equipment and different applications. What we are starting to see now that PAL is in place, and the ability to diversify network deployments, is the beginning of private enterprise and private networks. And this is really an area that began with 4G and is present, but nowhere's near the scope of what can be presented through CBRS. So if you looked at Mark's chart when he put it up earlier about the growth of people coming into CBRS, expect that this segment, this market for private enterprises and private networks will grow exponentially. This is because there's 150 megahertz of spectrum in CBRS, a portion of which can be used for designating for private use, whether that's through corporations or businesses, and they can be in diverse geographic areas. And we expect them, different ISPs and different providers, whether they be cable providers or cellular providers or fixed providers, to come in and create these private networks, which will allow for very designated uses and security in smaller areas. We're seeing the growth of municipal and co-op services. This is the offering of internet services or support services for equipment, which might be utility services or monitoring or SCADA, being offered through municipalities, counties, and co-op services. Clearly, COVID was a big driver of the use and need for additional spectrum. And schools, while they may have closed their main facilities, were pushing out and continue to push out a lot of their content over the air. And so we have seen both K through 12 and higher education spikes, especially through WISPA. We've seen tremendous spikes in this area where schools are using outbound push, and they're beginning to use CBRS to do that. If you run a multiple dwelling unit or a multiple tenant enterprise, and a substantial difference between those are one is residential and the other is business based, but it's a multiple tenant basis, you are and can use CBRS as one of the mechanisms for deploying your both mobile and fixed uses, and that is growing exponentially. And large venue facility operators are using CBRS. With the opening of PAL and coming into some newer technologies, we can expect neutral host operations. If you don't know what that means one to many or many to one, actually. It means that a lot of ISPs can aggregate through the same equipment and deploy through a single provider of systems. So you might have an AT&T or a T-Mobile or anyone connecting in all through the same equipment and utilizing that equipment through a neutral host. And we do expect to see quite a bit of that coming in the future. Oil and gas and energy are another sector that we're seeing a lot of growth because of the transition from Part 90 to 96. Let's go on to the next slide. So the next 3 slides, and I'm going to go through them very quickly, are vertical market segmentation that we are seeing use already to have deployments in CBRS. And I wanted to just mark a few statistics. Over 50,000 deployments have taken place in the first year of CBRS to residential and home facilities via WISPs. That's just one segment in one area. Where the transition from Part 90 to 96 pushed a lot of people who were using 3.65 Part 90N licenses into CBRS. So they're sort of seed networks. You take a network that was existing in 50 megahertz and you put it into a larger spectrum base with clean spectrum, and you put it through the SAS system and you deposit it in Part 96, and it will begin to grow, which means each one of those networks that Matt indicated isn't going to stay stagnant. It's going to grow and replicate. So a very big vertical market segmentation is residential, home facilities, and related areas. There's an extremely long list that I can't go through here of subcategories under each of these bullets. If someone is interested in that, please feel free to reach out to me and I can give you the long list of market segmentation. Obviously, businesses of all size and corporate are using CBRS and fixed services, especially as a supplement to their existing services and as new replacement services. Industrial and supply chain businesses are big users, and we are seeing a lot more IoT and IIoT, which is sort of what we used to call SCADA. So where there's monitoring of devices, geo-fencing, application design, many things that use a lot of fixed sensor-based devices are going through CBRS. During COVID, an awful lot of entertainment facilities and venues weren't allowed to invite in a lot of people, but they were still allowed to do their outbound work. So entertainment facilities started to use CBRS, and you're seeing quite a bit of that. Let's go on to the next slide. Already mentioned schools, both K-12 and higher education, and the energy and utility sector. The energy and utility sector, especially looking at the next bullet, oil and gas regeneration and resources, we're very heavy users of 3.65 and the 3.65 band, and therefore they have also begun or have migrated into CBRS. So we're seeing a lot of that. With the definitions that WInnForum created about indoor and outdoor, mining has become a mechanism for CBRS deployment, and a larger and perhaps one of the largest growing segments of CBRS is precision agriculture and the use in farming and in dairy, which are vertical segments that we can only see grow rather large and rather fast moving forward. Transportation infrastructure, municipal, we mentioned co-ops. Let's move on to the next slide. As you can see, because I dedicated 3 slides to this, there's just no end to the deployments. And by the way, every single one of these that I'm mentioning, there are case studies to demonstrate the use in CBRS and successful use. Certainly in public spaces, and another area that has got a lot of play during COVID, during the pandemic, was healthcare, hospitals, medical related, and telemedicine. The ability to deploy nodes in spaces where people could get healthcare, where doctors can transfer imagery. CBRS is perfect for that. And we've also seen the financial industry adopt CBRS as a method of working, as well as hospitality, retail, and exceptionally during COVID, houses of worship. Let's move on to the next slide. So one of the great things about this experiment in this new approach to use of spectrum is that it allows very distinct tiers of operation. Of course, we have the incumbents, which include the fixed satellite systems and the U.S. government's radar systems, and formerly the grandfathered wireless operators that were in 3.65. Most of them, as Matt indicated, are now migrated into CBRS, which leaves us with the incumbent operators and essentially two major tiers of operators operating within CBRS. That's GAA and PAL, which is now online. And GAA provides a low-cost, dedicated, licensed by rule solution, which is available in a less cluttered and more populated environment than Wi-Fi, or less populated environment than Wi-Fi. I want to make it clear, because people ask me this all the time: is CBRS a replacement for Wi-Fi? Do we put them side by side and say the uses have to be evaluated one against the other? And the truth is, they certainly can be. CBRS can be a replacement for Wi-Fi, but I think you will find, certainly for the next 5 or 10 years, it's a complement to Wi-Fi. You use them together, you use them in different ways. They work well together, and expect that Wi-Fi isn't going away anywhere soon, and with the advent of 6 gigahertz, certainly going to be expanded. So capacity is everything, spectrum availability is everything. I think both of them will continue. One of the great things about this band is PAL, in that you can get a licensed-like access to CBRS through PAL. I know the auction is done, and that means all of those diverse operators are able to begin to use and launch their networks. And one of the things that we will see very, very soon is a great expansion of the use of CBRS through larger network deployments, which will happen through PAL. But as Max indicated, there's a secondary market available, and I saw a question come up earlier about why the heck would anyone want to lease off their PALs? Remember, PALs are deployed in counties, and that means that network operators who purchase them, they purchase them for specific use. Not every one of those network operators is looking to use their entire geographic region or their entire spectrum that they purchased, and that gives the opportunity for them to get an economic return. If you don't use your PAL, the PAL space, or the space that you would use for PAL, that you would record a PPA for, is GAA. So if you want to get an economic return, if you want to allow someone to have those rights or portions of those rights that you're not using, you get an economic return, and the lessee or the person who you sell that portion to gets a much less expensive access to the PAL. Let's move on. All right, my last slide here is what do we do at WISPA with regards to fixed wireless? I covered a little bit of this before. The transition from 90 to 96 is 50,000 units in CBRS. We answer to a little over 7 million subs across the United States. So this is a growing segment. WISPs operate very heavily in residential deployments in both rural and suburban areas. There are, as we noted, advanced uses in shopping malls and retail centers and urban centers, and MDUs and MTEs and entertainment centers. Overall, anywhere that you can deploy fixed wireless, you're likely to see WISPs who operate mostly on a point-to-point and point-to-multipoint basis, but they also use hybrid models, which include many different ways of serving customers. I want to highlight one last thing that CBRS has become very important to in the use and deployment, and goes across most of the markets. There's a lot of talk about infrastructure growth. There's been a lot of talk about subsidies, and many agencies, both at the United States government level and at the state level, are offering subsidy programs where CBRS is becoming a major component of the bids in order to meet those subsidy programs. A couple of examples where WISPs have played a role include CAF2, RDOF, CARES, the Department of Agriculture's RUS, and more. So what we've talked about today is how diverse CBRS is in terms of the market deployments, all of the different vertical marketplaces that can be accessed, the number of different ways it can be deployed, and the absolute intensely good growth that's expected from CBRS moving forward. Thank you very much.
Thanks, Richard. That was a really good rundown. I have two questions. The first one is, you did a really good presentation of the use cases. Do you think there are any use cases or verticals out there that are uniquely suited to CBRS? Or in other words, CBRS really fits into those use cases very well?
Yeah. So, well, as someone who runs and works with WISPs, certainly the rural residential and suburban residential deployments are really good because it's clean spectrum. Where the signal can be deployed without having too much in the way of clutter and noise issues. It's mid-band spectrum. It's perfect for that. I'm getting more and more contacts. In fact, WISPA now has a full committee on MDUs and MTEs, where rooftop use, both in urban and suburban areas, are really well suited with CBRS. And I think that moving away from what WISPs do particularly, but it is certainly something that a WISP can do. The idea of private networks and neutral hosts are really well suited with CBRS.
Great. And my second question is, looking at your video feed, I noticed that big gray thing on the shelf behind you, and I just was curious as to what that is.
This big gray thing is for
Yeah.
those of us who don't have very good vision, who need to have extra light. It's a
Oh, okay.
it's a light with a lot of intensity that would blind most people, but for me, it allows me to see.
Okay, well, that's very cool. Okay, you solved a mystery. Thanks very much, Richard.
Absolutely.
Okay,
Thank you, guys.
next up is Andy Clegg. Andy's going to be talking about Release 2 standards. So Andy, it's your nickel.
Yep. Okay. Thanks, Mark. So I'll try to be quick so we can save time for questions. If you go to the first slide, Mark, and I'm speaking in my role as the chair of WINForum Spectrum Sharing Committee Working Group 1, which creates the functional and operational standards for CBRS. So what's out there today, the spectrum access systems that are operating today and the CBSDs that are operating today are operating under our Release 1 standards. And so SASs were certified, approved by the FCC, a year and a half ago. And they were certified based upon our Release 1 standards. But what WINForum has been working on in the meantime is an evolution of the standards to Release 2 that will provide more functionality compared to what we have today. What we're operating today, and we realize, CBRS is working great, but there are also features we'd like to see in the future of CBRS. So we're working on these Release 2 features. Now, at the moment, there's no absolutely defined path for implementing Release 2. We're still working with the FCC as to whether SASs need to go through further certification or something like that. But there are some features that we would like to implement in Release 2 that really don't have any impact at all on Part 96 or CBRS rules. We believe we can implement those without breaking the certification we're already operating under. And then there's other new features that would have to get the approval of the FCC. Because they may impact protection of incumbents or something like that. So we're still working on this, and the Release 2 features, the ones that aren't regulatory impacting can be deployed relatively soon. The ones that are regulatory impacting might take a little longer to deploy. Anyway, you can go to the WINForum website and you can look at our Release 2 standards, and our Release 2 technical specification is 1001. There's a link for it on the slide. You can go there and you can see some of the features, some of the newer features we are currently, that we've already approved for Release 2. And then I'll also talk about some things we're working on. So next slide, please, Mark. So the cool thing about Release 2 is that only one of the Release 2 features is mandatory if you want to do Release 2. The rest of them are optional. In other words, SAS administrators and CBSD manufacturers can pick and choose which Release 2 features they want to support. But if they're going to support Release 2 at all, there is one feature they do have to support, and that's capability exchange. And it's really just kind of a common sense thing. The capability exchange is just the ability to tell a SAS or a CBSD that the other entity supports Release 2. So if you haven't upgraded your SAS to Release 2, or the CBSD hasn't been updated to Release 2, it won't understand anything about Release 2 or Release 2 features. And so everything will fall back to Release 1 by default. But if you have a SAS that has Release 2 capabilities and a CBSD that has Release 2 capabilities, those two entities need to talk to each other and understand what capabilities they support under Release 2. So again, if either side seems confused by the question, what do you support under Release 2, then both sides default back to Release 1. But if both sides do support release 2 and support certain features of release 2, then they tell each other which features they support. And that's the purpose of this capability exchange. So if you want to be a release 2 SaaS or CBSD, you need to at least support capability exchange. Everything else is optional. So let's go to the optional features. Next slide, please, Mark. So one of the optional features is grouping of CBSDs. So this basically allows CBSDs to identify themselves to the spectrum access system as a member of a group or a clique or however you want to, or a gang, whatever you want to say. This is useful, for example, if one CBSD is providing service to another CBSD, like a customer premise equipment or something, and then you want to associate those two as always needing to be sort of managed together because they're both talking to each other. Another example is if you have a distributed antenna system, a DAS, that's built upon CBSDs, you want all of the CBSDs to operate on the same frequency, and so they identify with each other. They identify to the SAS as all belonging to the same group, and so the SAS knows to treat all of these CBSDs in the same group in the same way. So the new release 2 standards have a variety of dealing with groups in the context of CBSDs identifying themselves as needing to work together with other CBSDs. Next slide, please, Mark. Another thing we've implemented in release 2 is enhanced antenna patterns. So right now in CBRS, when we do the interference calculations in the SAS, all we take into account is the azimuthal antenna pattern. But you can down tilt your antenna in order to put the radiation where you need it and throw less radiation towards the horizon. And so you might actually be causing less predicted interference to an incumbent than is evident, because even though in that particular direction your antenna, not taking into account the down tilt, has a certain gain, if you incorporated the down tilt in the calculation, the gain in that direction towards the horizon might be considerably less. Right now, SASs don't take into account the vertical antenna pattern, but we've now implemented a release 2 feature where they can take the vertical pattern into account. And so this is going to allow us to use spectrum a lot more efficiently. However, we've had some discussions with the FCC on the current implementation, and we are working with them to tweak that implementation slightly to reflect some observations that they've made. So even though it's in the current standard, there's a new standard eventually that will, an updated standard that will tweak those that release 2 feature slightly. That'll be coming in the future. Next slide, please, Mark. We also have a very basic feature that just identifies if a CBSD is working as a CPE, a customer premise equipment, and is in conversation or communication with another CBSD, it can identify itself to the SAS as a CPE CBSD. And there are, on occasion, some things that a SAS will do that are different for a CPE CBSD than for a regular CBSD. So it's necessary to be able to identify. So this isn't a an earth-shattering feature, but it was identified as a feature that would be useful to have. Next slide, please, Mark. Passive DAS. So we now support passive DAS. So for example, you have a collection of CBSDs, or you have a DAS. Let's say so a passive DAS is you have a central transmitting unit, and then its signal goes off into a whole bunch of individual transmission points. It's split off literally by a splitter to all of these different transmission points. Well, passive DAS allows you to transmit power in that central unit that's more than what would necessarily be allowed by a CBSD, and then treat all of the individual transmission points as the CBSDs. So the central unit could put out, for example, 10 times the allowed power of a CBSD, but it goes out to 10 transmission points, each of which is operating at or below the power that's allowed by a CBSD. And so this is allowed under the release 2 feature supporting passive DAS. And by the way, the elements of the passive DAS typically all report to the SAS as the member of the same group, and it's a group that has to basically be all or nothing. So every one of them needs a grant on the frequency that the DAS is operating on, and if one of those transmission points can't get a grant on that particular frequency, then none of the DAS transmission points will get a grant on that frequency. So this is a way to manage interference in the vicinity to incumbents in the vicinity of the passive DAS. Next slide, please, Mark. So this is a feature that's in progress in a version of the standard that hopefully will come out soon, but a grant update. So the way we have it right now is that if any parameters of a grant to a CBSD changes, the CBSD has to relinquish the grant and request a new grant and go through an entire process to request a new grant, and that can create a delay in continuing to operate. But let's say for some reason a CBSD is determined that it needs to reduce its power in order to be more compatible with incumbents in the area. It seemed to us that the SAS should be able to communicate directly to the CBSD and say, hey, we need to change your grant. You now need to, transmit 1 dB less power than you were transmitting before. And it occurs to us that this shouldn't create the need for the CBSD to relinquish its grant and start the process all over. It should simply be able to update the grant it has and say, okay, yeah, I'll transmit 1 dB less, but I'll use the same grant, and the new grant and this grant will now have 1 dB less allowed power. And so we're working on standardizing that. Hopefully we'll be in the release 2 standards soon. And then I believe that's it, Mark. Go to the last slide. Yep, that's it. The collection of all of our release 2 standards for WINForum are at the link that's shown there. And release 2 is extensible and is being updated constantly. We have a bunch of future features for release 2 in the works that we're hoping that will be approved for the standard shortly. So please stay tuned, and if you're a WINForum member, we invite your participation in creating Release 2 standards and features. So that's it. Back to you, Mark.
All right, thanks, Andy. I note that if we ever do the CBRS wrap, we have to figure out how to work passive DAS on a SAS into it somehow. One question I do have is, how will this be tested? Because I know there's a lot of features here, probably more features actually than we had in the original spec. Any thoughts on how we would test this? And while you're doing that, I will get everybody else up here. You're on mute.
Sorry, should test my mute. Yeah, so there are several thoughts on this. There are some new features like the grouping. I mean, that really has no impact on anybody. Or identifying yourself as a CPE CBSD, that really has no impact on any aspect of incumbent protection or PAL protection or anything like that. And we believe those can be implemented without additional testing. It's those are very minor, functionally very minor and non-regulatory impacting. We believe some updates that that are regulatory impacting but still relatively minor could potentially be self-certified or self-tested or third-party tested just to make sure that they're working right. And then finally, there are some features that we believe probably are going to need perhaps some kind of regulatory recertification. So for example, if we decide to implement the ability to use vertical antenna patterns in the protection of DoD incumbents or something, we believe that the FCC probably will want to have a say in how those new features are certified. So we believe there's various levels of features that we're implementing here that range from, we should be able to implement them without any problem, just put them in the new Release 2 SAS and continue operating, all the way up to things that we think the FCC may want to have a say in. And so we believe there's sort of a variety of ways that our future Release 2 SASs may be certified.
Okay, cool. All right, well, let me get the rest of the panel in.
Hey, Mark, can I elaborate on what Andy said there a bit while you're getting the rest of the panel in?
Go for it. Yeah, surely.
Sure. So the WINForum, for those sort of the middle bucket of features that Andy was talking about, the WINForum has a certification program that we've already set up. It's for those companies who want to claim compliance with the Release 2 standards, and it allows them to self-test, and the process allows them to self-test and then submit the results of their test to claim compliance, and then we will post the full list of organizations that are showing with the features that they're showing and against the various equipment on our website. So that compliance program is open and available, and the SaaS to SaaS spec test spec was just published, so we're hoping to start populating that shortly.
Thanks, Lee.
So Mark, just wanted to. I am also the chair of the work group 4 who developed this test and certification program. Now we have 3 documents, 4003, 4004, and 4006 to address these test cases. If you are a member of WInnForum, you are welcome to look at these documents or attend the work group 4 sessions that we are developing the test case for all these features. Thank you.
Thanks, Masoud. And before we get started in the Q&A, we have about 10 minutes. I want to make a shout out to Al Jetty. I understand Al is watching today, and Al was one of the early ones too. Al was the document editor on the specification, and Al did yeoman work on that. So Al, if you're out there, I hope you're well. Thanks for participating. Okay, well, we had some questions come in. I'm going to run down through the list and see if we can get through them. The first question was, if someone can answer it, are CBRS 5G deployments non-standalone? Anybody want to take that?
I can talk about that.
Go for it.
Yeah. So the CBRS, the development of 5G on CBRS is irrelevant whether we are using non-standalone or a standalone. In other words, CBRS allows both operation of NSA and SA operation for 5G and R. You can use a CBRS channel individually and standalone for 5G operation, as well as you can combine that with any license or another CBRS channel as part of the kind of between 4G and 5G as part of a non-standalone. So both operations are allowed under CBRS.
All right, thanks, Masoud. Anybody else want to talk on that one? That sounds like a pretty definitive answer. Okay, here's an interesting question that came in. Probably I can see why someone would ask that. Why is PAL leasing necessary or useful? Why are we spending so much time and effort here? Notwithstanding the fact the Commission addressed it in the rules. And then the other sub question to that is, what use case gaps is this addressing that is not already covered by the PAL licenses and GAA? So, Max, you want to take that?
Sure. So far, the 10-year terms and the whole county size, those are useful to wide area providers. But for someone who's not a wide area provider, just a point of use, say a hotel would be a great example, who wants priority access to the channels, either for a long-term basis, maybe they install a network in their hotel for their guests, and they only want it on their property or right around there, so they want to lease the rights from someone who has the whole county. Or maybe they only want it temporary. They have a conference and they're going to have 100 guests, and for a week they want to have this and install a special system to work for the week, and they don't want to lease it for 10 years. So either by area or by time, they don't want to pay for an entire county for many years.
Okay, I'd say another reason for secondary market is there's always a secondary market for spectrum, especially when it's auctioned. So I'm not sure that there is any band that's been auctioned for which there isn't some sort of secondary market. So, but that's a good point. Thanks, Max. Any other thoughts on that question?
Yeah, a couple of things. Smaller operators, smaller networks that are seeking to have sections or areas or regions of their networks operate on PAL, but could not afford to buy them during an auction, or didn't buy them during an auction and now have a present need to do that. They can gain access to these smaller areas to do their networks, to either fill in gaps or to provide for their entire network. If you were to take, for example, since everything was done by counties, you take Los Angeles County. Well, certainly Los Angeles is in demand, but maybe 30 miles out of Los Angeles, there's areas there that are not necessary for the main provider, and they can get economic return by leasing that section, and a rural provider that's providing something in that area can use it and have those protections.
Okay, thanks, Richard. Question for you, Masoud. Going back to your PAL channel, can you talk about the repetition of PAL channel swapping opportunities?
Yeah, thank you. Sorry, I forgot because of the time. Forgot to mention. So we have decided to rerun the PAL channel swapping process in a kind of biannually. In other words, we are going to have another opportunity for PAL channel swapping perhaps within 6 months, in October, 5 months, within October timeframe. And we are going to define the process hopefully soon. We are going to inform the PAL licenses. So I would insist that please, every PAL licensee, be cognizant on the email that you receive from the CBRS_PAL_channels and at outlook.com. That's an email that we have chosen to communicate with all the PAL licenses. So soon they are going to receive that. In summary, I would say that perhaps around October, they would see another opportunity for channel swapping among operators or to unassigned channels.
Okay, thanks, Masoud. Another question came in. What's the near-term outlook for supporting neutral host in CBRS?
So, Mark, if you allow me, I just give one comment and then
Okay.
I allow other friends. And I talk about that as I'm also the chair of the CBRS or Ongo Alliance Network Services Task Group. We have already defined the way that CBRS Alliance can run the neutral host in a way consistent with what Multifier Alliance defined. So that's one way that the neutral host can be defined. So and also you know that with the use of the concept called the SHNI, shared HNI, we allow private network and enterprise to use CBRS independently. However, just want to add that that doesn't necessarily preclude to use other ways of deploying neutral hosts, such as using MOCON or MORAN or any other shared network share approach. So my answer is that with the combination of using shared HNI, the CBRS Alliance defined the neutral host process, as well as other mechanisms that 3GPP allows the sharing, such as MOCON and MORAN. There are vast different use cases and scenarios that neutral host can be done in CBRS.
Okay, thanks, Max. Masoud. Any other thoughts on that question, Max?
Yeah, sure. I think it's a complex problem because besides the network identifier that Masoud alluded to, and whether you're using, a new network identifier for the neutral host, or essentially camping on a network identifier by a sponsor, the other problem is authentication, and whether you're going to use the sponsor's authentication from the device, in which case you're captive to the sponsor, or whether you want the neutral host then has to be able to access all the different sponsors. That's kind of part of MOCN. So I think it's a difficult problem. I think it's going to take a while, especially if the neutral host is truly neutral and not affiliated with a sponsor. If there is a closer relationship between the neutral host network provider and the sponsor, then it's easier, it's contractual, and there's a way to do that. But if you really want the concept of an open neutral network that can host devices from any provider, that's a much more difficult problem.
Okay. And I think we have time for one more question. I'm just trying to find the right one that we could probably answer quickly. I guess the last one that came in, someone's asking, what, if any, is the relationship between unlicensed CBRS and NRU from 3GPP? I think it's a fairly straightforward answer, but I think with respect to unlicensed CBRS, they mean GAA. Is there any relationship between GAA and NRU from 3GPP? No. Okay, so that was an easy question. I had a bunch of questions that I put together. Let me see if I can find one that we can do quickly. So in the next 3 minutes, this is not something any of us spoke about today, but it is out there sort of in the ether. Proposal for higher powered devices, category C and D, have been proposed. Not just DISH, others have proposed it too. In fact, there was another proposal that hit the docket just yesterday. Anybody want to comment on thoughts around, maybe not whether it's a good idea, but with higher power operation, what would that do for CBRS? Is that good or bad? And for anybody that's not aware, the proposal is to have two new categories: a category C, which is 158 watts per megahertz, and then the category D, which is 10 times that, or 1,540 or so watts per megahertz. So any thoughts on whether CBRS could support that, and what would be the issues?
So Mark, we can also discuss politics and religion if you'd like.
That's why there's only 2 minutes left.
Yeah. No, I mean, I don't, as a SaaS administrator, I don't have any, feeling one way or the other as to whether it should or shouldn't be allowed in CBRS. From a SaaS perspective, it's a software update to be able to support different powers in the CBRS band. So from a SaaS perspective, there's no, complicating factor. It does introduce, you've got to keep in mind that the protection of the DoD incumbents and the protection of fixed satellite service, and even protections of PALs from each other are based fundamentally on the amount of power that a device is putting out. So if you allow devices that operate at considerably higher power levels, we have to reformulate, for example, the coordination distances over which we have to consider devices as potential interferers, those types of things. So for those of you who are familiar with the concept of the dynamic protection areas and the DPA neighborhoods, the neighborhoods could grow for these higher power devices. The setback distance for fixed satellite service earth stations could grow, that type of thing. So it's just, again, I don't have an opinion one way or the other as to whether higher power should be allowed, but it will change some of the distances and coordination aspects of dealing with incumbents. And the last thing I'd note is that we do have high power neighbors coming in on either side of us, very high power neighbors just below in the 3.45 gigahertz service and just above in the 3.7 gigahertz service. So this puts CBRS a little more on par with the kind of powers that we might see on either side. But at the same time, it changes the concept of CBRS a bit. CBRS was really for fill-in and sort of democratized spectrum access, not really designed for big macro cellular networks. So it changes sort of the characteristics of CBRS a little bit. But again, as a SaaS administrator, we don't really have an opinion one way or the other. SaaSes can support whatever powers want to be run in CBRS. And so, it'll just be really kind of, it'll be a sense of, what comes out of the commission on this if they decide to entertain that concept.
Okay, thanks, Andy. We're at time, but I'll let Max and I think Richard had his hand up. So go ahead, Max. You can be brief, and Richard.
I think it's a balancing act, as Andy just said, between the usefulness for the air interface versus the burden of interference analysis for the SaaS and the other users. I would add that probably the best way is to bound the use case and basically say, in very low density rural areas that are away from the coast, higher power makes, the interface more valuable and worthwhile, and, probably doesn't pose an interference risk to more users or to, the tier one incumbents. And in more urban areas and near the coast, probably, very high power levels should be banned. So the rules probably have to be written around not only the power level, but the use case and where it's allowed.
Okay, thanks. And Richard, final word.
Yeah, just I think it's not a simple issue. It's a simple implementation issue in terms of the SaaS permitting it, but I think it's a very complex issue in terms of the rules and the way in which it affects the various types of users. There are, because it's a technology neutral band and because there are so many different types and sizes of users, I think it has a huge impact on some users while others may benefit from it. So I reserve the right to say we really need to look at it very closely with respect to how it's going to impact various users. Up front, we're not in favor of it.
Okay, thanks, Richard. Well, we're at time. Thanks, everybody. So that was the future of CBRS looks pretty bright. There's a lot of work to do, but it took a lot of work to get here. So I'd like to thank my panelists, Matt Mangriotis, Masoud Olfat, Max Solondz, Richard Bernhardt, and Andy Clegg. So thank you guys for the time and effort you put into this, and back behind the scenes were Stephanie and Lee. So tune in next when we will deal with politics and religion.
Hey, Mark, one thing, there were a couple of unanswered questions in the queue.
Yeah, I know.
We'll try to we'll answer those offline and email to the participants.
Yeah, I'll put them together and send them around, and we'll try to answer them. Thanks. All right, thanks everybody. Thanks again. Lee, back to you.
All right. Well, thanks everyone, and we'll let you know when our next webinar is going to be. And until then, hope everybody has a good weekend.
All right, take care. Bye, everyone.
Bye.
Thanks, guys.